Hey everyone, welcome to another video of Roman Just Codes. I'm Roman, and in this two-part video tutorial of the Angular PWAs and Google Maps series, I'll be implementing real-time location updates using Google Maps and Firebase Cloud Firestore. Here's what we'll be implementing as a whole. As the device tracks the user's position in real time, it will push the location information to Firebase, which in turn will broadcast it to any client that's listening for these location updates, allowing the device on the other end to update the first user's position on the map in an asynchronous fashion, keeping everyone in sync thanks to the power of Firebase Cloud Firestore. Let's see this in action. Picking up on our previous videos where we've been building a fictional package delivering app called UPS, imagine having two instances of the same application open. In one, a user logs in as the driver who will deliver the package to a person. They provide the initial information of where they are, and as the driver moves along the route towards the package's destination, the app broadcasts the status of the driver's location to our system via Firebase. In the other instance, another user logs in as the user receiving the package, and they want to know with exact precision where their package is and when it will arrive. They should be able to receive real-time information about the location of the truck as it approaches its destination, even if they log out of the system and log back in a little bit later to check on the status. Without missing a beat, the application is in sync, providing our users with the most accurate information of the location of their package. I'll explain in detail which are the pieces involved in order to make this happen throughout this two-part video tutorial, so make sure to watch both parts. With that, let's proceed. In the previous episode, I set up a free hosting environment in Firebase so that I can leverage the SSL certificate provisioned automatically with every Firebase account you set up, so that I can use the Google Maps on, for example, Safari on iOS, since Google Maps doesn't work on Safari iOS unless it's under HTTPS, and I wanted to have this app public so I can consume it as a PWA. So check out that video as I'll be tapping on some of that configuration. Let's do some coding. In my map page, where I have already set up Google Maps with the Directions API, Places API, and even obtaining the user's current location, I'll be leveraging another cool feature from HTML5's Geolocation API called Watch Position. I'll create a member variable called Location Watch ID, where I'll be holding a reference to the Watch Position API invocation. As you recall, the existing navigator.geolocation.getCurrentPosition gets the user's current position as a single call with a single response, the user's current position as a lat and long coordinate. This method gets the current location of the user and stores it as the destination, at which point we initialize the map, set up the initial pin, its click event, etc. Now, right underneath it is where I'll perform the call to watch position and store it in my location watch ID variable. I'll call it off of the navigator.geolocation.watchPosition, which takes a callback that returns several arguments. But for now, we're only interested in the show location callback and the error callback. The watch position method retrieves periodic updates about the current geographic location of the device. The location is expressed as a set of geographic coordinates together with information about heading and speed. The location information is returned in a position object, and each update returns a new position object. That means every time the user's location changes, you'll get a new position. You can optionally provide the error callback, where you can handle any issues regarding collecting the updated user's location, and an optional third argument called options, which I'm not providing at the moment. In the show location callback, where we receive a position object containing the returned location information, we'll parse the information and assign it to the source variable, which is a lat-long literal from the Google.Maps API, and takes a single lat and long. Get the location values out of the position object's coords, latitude, and longitude respectively. check whether the source pin marker is available as well, so we can assign its position based on the newly received position from the watch position call. Believe it or not, this is the minimum information you need in order to get this to work, and so you can see the marker pin moving along a route as the user moves and the device collects position information in real time. You capture the position object received every time the user moves. And on every new position received, you update the position of the marker via the marker's setPosition method. Simple as that. Now, how do you test this and check if it's working? You either need to test it on a real device or a simulated device, like an Android or iOS simulator, and for that your app must be running under HTTPS. What I'll do is I'll deploy this app to Firebase and access it via the iOS simulator. First, I'll build my app for production. Then, I'll deploy the build package to Firebase Hosting. I'll check whether I'm logged in under the right user. And done. I'm on a Mac, so let's fire up the emulator and test. Launch iOS Safari. Add the app to the home screen. Launch our PWA. Sign in using Firebase authentication with a Google account. You should receive a two-factor authentication notification on your phone. Select yes on your phone and proceed. The red pin shows the destination, or your current position, being picked up by the iOS simulator, which is a bogus location. Set the source location via Google Places API, so I'll just pick a location friendly to the emulator. Okay, now I have my source and destination. Now let's check out the pin moving by finding the location option in your iOS simulator under Features, Location, and I'll pick the Freeway Drive option. This will constantly send an updated location to my application while simulating a drive on a freeway. And there you have it. Our pin is moving as the simulator is broadcasting a new location roughly every second, and our application, via the Geolocation's Watch Position API, picks it up and updates the marker pin's position by assigning the new position received to it. Let's go to the Firebase console of our existing project. In my case, it's called UPS Tracking. On the left navigation, click on the Cloud Firestore option. Cloud Firestore is a flexible, scalable database for mobile, web, and server development from Firebase and Google Cloud Platform. For the purposes of keeping your data in sync across client apps through real-time listeners for mobile and web, it's the perfect solution, so you can build responsive apps such as this one. Cloud Firestore is a NoSQL, document-oriented database. Unlike a SQL database, there are no tables or rows. Instead, you store the data in documents, which are organized into collections. Let's create a collection called Location Updates. Inside this collection, we will have a single document for now, which I will uniquely identify by using a GUID as its name. I'll use this document to encapsulate the communication between the two users, the one pushing its location changes and the one listening. In a real-life scenario, this is the way it could potentially be. A single document per package delivery or source-destination pair, where the driver saves the updated location and the corresponding package owner reads it out of. That way, you can simultaneously maintain multiple users under the same collection, all reading their corresponding documents and not affecting each other. Under this document, I'll add two map types or dictionaries called source and destination. Each of which will hold the location information also as a map with a lat and a long. Each source and destination will have the UID associated with the logged in user. So each user knows which section of the document to update for themselves and which one to read from the other person. Source will be the driver, destination will be the package receiving user. The UID will be supplied by the Firebase authentication feature we implemented in previous videos. Each logged in user has an associated unique ID when they log in via Firebase authentication, and that's what we'll use to uniquely identify them. Let's finish adding the fields for the source portion of the document. Add the location, also as a map. Each lat and long will be type number. Add the UID field for the source object as well. And last but not least, a common field for both of them called route. This will store the JSON serialized representation of the route as we receive it from the Google Directions API, so the destination user doesn't have to make the call again to fetch the route information. All they have to do is just grab the JSON serialized route, add it to their directions renderer, and it should draw the route and polylines on their map. With that done, let's hit save. As you can see, our document structure is well defined and self-descriptive. We have a single collection with a single document, and the document has fields for source, destination, and route. For the sake of this tutorial, I already know what the IDs for each of the logged in users are, so I'll plug them right away into the model. That way, when they log in and fetch the data, they already know who they are and where they need to place their info. I'll empty out the route information for now, so we see the actual info when it comes in. Let's go back to the project and hook up the Firebase connection so we can both push data to Firebase and listen for updates in real time. Let's go to the top in order to create some variables we'll need throughout the rest of this example. I'm going to need a variable to hold the name of the document we will update, the name of the collection that contains the document we will update, and again, just for the sake of this tutorial, I'll hardcode both driver and recipient ID so I can conditionally execute logic that corresponds to either user. Let's recap again on what we have in Firebase. I have a collection named Location Updates. I have a single document, and the document contains the information that it needs to update the map pins for both users, as well as the route information in real time. Let me grab the unique ID for the logged in user corresponding to the source location, which is the driver ID. I'll grab now the destination location UID. I'll store it inside the recipient ID. I'll hold a reference to the ID of the document. This ID can be anything. I generated it randomly, which should be random if this system will hold multiple documents that will map to multiple package delivery sessions between drivers and recipients. I'll store it on the location update doc variable. While I'm around here, I'll switch the auth user from being an observable to just being a regular user member variable, since I need the unwrapped value accessible from TypeScript. I'll create a corresponding subscription member variable as well to properly do the cleaning up of the subscription. Instead of getting a raw observable out of the getLoggedIn user, I'll subscribe to it, which will unwrap the user value the returning observable brings. Assign it to the auth user variable. As mentioned, implement the ng-on-destroy lifecycle hook so we can do the cleaning of these subscriptions. While I'm at it, I'll also dispose of the location watch ID in here, since I missed doing it earlier. Use the clear watch method out of the Geolocation API. Let's go back to the watch position method. Some of the code that I'll be implementing here will only pertain to the user that logs in as the driver, so I'll explicitly add logic for that. Again, for the sake of simplifying this tutorial so you can see. In a real-life scenario, make sure you implement user registration and role assignment, whether they can be a driver or just a user checking the status of their package. So this is what we'll do. If the authenticated user is the driver, that's the user who will be pushing the updated location as it gets picked up by the device and captured by this callback, so all this logic should be inside this block. We update the source position and its corresponding pin locally so I can see it move. Now, if I want other people to see my every move as well, then I'll have to broadcast it. How? Well, pushing it to Cloud Firestore and to the document I set up earlier. Whoever is registered or listening to changes on that document will receive the updates I push to it with very low latency. In order to push values into Cloud Firestore, I already have Angular Fire installed. So all I have to do is import into this page the corresponding package, in my case, Angular Firestore. This package, in conjunction with the configuration I have on my firebase.json file in this project, will do the connection to Cloud Firestore seamlessly. Let's inject it in the constructor under a private reference called Firestore. And this is how you talk to Firebase Cloud Firestore. From Firestore, you first reference your collection, in my case, location updates, using the collection method. Then the child document, in my case, the unique GUID, using the doc method. Then you call the set method, which takes as a parameter a JSON object containing one or more fields from the document in question. From this document, I'll set the source object. Remember, the source location is the driver's location. So pass the location as a nested object containing the lat and the long coordinates. I'll be setting the UID from here to make sure it falls under the source portion of the document. Remember, the UID comes from Firebase authentication. I'll use the merge true option when setting values on a document. I'll use the merge true option when setting values on a document, because if you don't offer this option, it will override your document content with whatever you pass in here. So later, you'll notice only the source option changing and updating as the driver moves, which is what we want. You'll see the lat and the long changing in a sec. That way, multiple users can access the same document and make changes to it. Let's build this for production and then deploy. Once the deployment is done, let's test it again on the iOS simulator. Do the same thing. Launch it on Safari. Add it to the home screen. Log in. The whole nine. Set the location as before. In the simulator, set the location to be a freeway drive again. And now check this out. As the driver pin moves, it not only shows it on the map right away, but also pushes its lat and long every single time it moves, doing multiple pushes to Cloud Firestore, denoted by the flashing on that portion of the document. Pretty neat. And with that, I'm concluding part 1 of this video tutorial. In part 2, I'll implement the recipient side of things and simulating the driver updating their location as they move along a route, thus bringing it all together. See you on the next video. That's it for this video, so please stay tuned for more upcoming videos. Hit the subscribe button to stay updated, and please like this video if you found it useful. Thank you so much for watching.